Okay. Today class we will discuss some application of the Rolle's theorem. Okay. In the calculus, you first we define the Rolle theorem, then we can do some problems based on the Rolle's theorem. Right. First, what is the Rolle's theorem? Rolle's theorem. Right. Rolle's theorem. Here is very important. This theorem is very important, right? Here you take let A be a subset of real number. One of the subset A be a subset of real number, and you take one of the function f from this set A to real number. It's a real value function. Be a function. Be a function with this condition. Okay, this a comma b is closed interval of a comma b subset of a, right? Closed interval of a comma b subset of a. Okay, suppose that f is continuous. F is continuous on a comma b and differentiable on a comma b if f of a equal f of b, then there exist, right? Then there exist, right? There exist C belong to a comma b. Can find such element C in the interval, open interval a comma b, such that, right, that derivative, this f dash of that point C equal to 0. Right, f dash of C equal to 0. What is this, right? From the geometrical representation, we can easily get the idea about this one. Suppose you have the point here A and B. Okay, you have the one of the graph. Condition is if A equal FB. FA means this point, no? FE means this point. Both are equal. Both are equal. Certainly, okay. Both are equal, right? Within this interval, you can find a point, such a point C, the open interval, right? Such a point C, right? This tangent, you know, it is a tangent, no? F dash means tangent. Here at that point, here this FC exit, at that point, what's the tangent? 0. 0, no? Understand? This tangent is 0. That one all is f dash of C equal to 0. You know, what is the meaning of f dash of C equal limit of, right? F of x minus f of C over x minus C. Understand? In the differentiable, no? F dash of C. What is the limit of fx minus fc over x minus c? That is a tangent, that f dash of C, that one equal to 0. 0 obviously 0, right? here at least 1 point, but it's more than 1 point also. This it is possible, right? Let check this graph, right? Let's check this graph. Okay. So y-axis. This point A, right? Then you have the values here, f of A. F of A equal f of B is f of B. It's B. Otherwise, this one f of B. It's continuously this graph. It is f of B. It is B. It is f of B. Okay. F of A equal f of B. They mention f of A equal f of B because here they mention f of A equal f of B. In this case, here there is one C, at least one C. But here, at least one C, no. Here there are so many values. In this point, f dash of, I think you can assume that this point is C. C. This one also within this interval A, B, this f, there will be this f of C1. Therefore, f dash of C1 equal to 0. Here, another point, C1. C2 is f dash of, f of C2. In this case also tangent is 0. That means f dash of C2 is 0. Similarly for C3, at least 1 point here. There are 3 points, this one satisfying this condition, okay? C3, therefore this f of C3, then its tangent is 0. That means at this point this tangent is 0. That means f dash C3 equal to 0, right? At least 1 point is satisfying, otherwise there are more points also satisfying, okay? Okay, right. Okay, this is the Rolle's theorem, right? It's a Rolle's theorem. Now we will do some problems under the Rolle's theorem, okay? Right. You can easily prove this theorem, okay? You can easily prove this theorem, but our purpose is we use this theorem and do some examples, okay? Okay. Suppose if they ask to verify the Rolle's theorem for the one of the function, right? Then what we do? That is your question now. For that, okay, for that, first you want to check whether that function is differentiable or not. Next, you want to check, suppose this differentiable, then you can easily say that is it continuous, because you have some, in the calculus you have some theorems. Suppose f is differentiable, then f is continuous. Then obviously you can, by the theorem, you can say f is continuous. Okay. Next, you want to assume, you want to check whether these two values are equal. You can take f of b and f of b, some points a and b. Condition f of a equal f of b. Then you can apply this theorem. Then you can say this f dash of c equal to 0. Then you can find that the c values within that interval. Okay, right. This type of question we will discuss now. So that function f of x, so that, okay, so that, right, so that the function, right, the function f of x equal e power x cos x satisfy the Rolle's theorem, satisfies the Rolle's theorem in this interval. So for the solution, your function is this one, f of x equal to e power x cos x. So e power x cos x. First, you want to from this one, f of x is differentiable. F of x is differentiable in minus pi by 2 plus pi by 2. Why? Since, okay, since e power x is a differentiable function, cos x is a differentiable function, the product function also differentiable function, therefore f is a differentiable function. Okay, right. It is as it is subproduct of the product of differentiable function e power x and cos x. Okay, I already told you, suppose this f is differentiable implies f is continuous. Therefore, obviously this f is continuous because differentiable exists, no? Therefore, f is continuous. F is continuous, okay, in minus pi by 2 plus pi by 2. You know, f is differentiable in this closed interval minus pi by 2 plus pi by 2 means f is, obviously f is differentiable the open interval because this open interval is subset of the closed interval, this interval, right? Therefore, because our claim, we want to show that f is differentiable in the open interval, okay? Open, here, f is differentiable in the closed interval, but this open interval is subset of this closed interval. Therefore, f is differentiable in the interval minus pi by 2 plus pi by 2. Okay, minus pi by 2 plus pi by 2. Okay, minus pi by 2 plus pi by 2. Now remaining, you have the condition you want to check whether this f of a equal f of b or not. Right. The a point a is minus pi by 2, no? F of minus pi by 2. E power minus pi by 2 cos minus pi by 2. Cos minus pi by 2, cos pi by 2, e power minus pi by 2, cos pi by 2. Cos pi by 2 0. Okay, therefore this one 0. Cos pi by 2 0, therefore this one 0. Now f of pi by 2, this one is e power pi by 2 cos pi by 2, this one also 0. Therefore f of minus pi by 2 equal f of pi by 2. Okay, f of minus pi by 2, f of pi by 2. Now, uh, now this condition satisfying, and f is differentiable minus pi by 2 plus pi by 2, and this product of differential function e power x and cos x. Now by the Rolle's theorem, right? By the Rolle's theorem, right? That means here this whole condition of the Rolle's theorem is satisfying. Therefore, you can find such a value c. Okay, such a value c within this open interval minus pi 2 plus pi 2. The derivative of that f dash of that c equal to 0. From that value, from that one, we can find that what is the value of that one, right? Within this open interval. Okay, right. All the condition of Rolle's theorems are satisfying. Okay. Okay. Of Rolle's theorems are satisfied. Now f dash of x, that one 0, no? Here, okay, f dash of x equals 0. Right. What is f dash of x? You want to take the derivative for that e power x cos x function, no? Then e power x cos means sine, no? Minus sine. Plus e power x again e power x cos x. So you can take outside e power x cos x minus sin x. Otherwise sin x, no problem, right? Okay, no problem. But okay, right. From this one we'll write I think cos x sin x minus cos x tan x e power x. Okay, sin x minus cos x is also okay. Then obviously this e power x is not equal to 0. Therefore tan x equal 1, x equal to, what is the solution, right? Is equal to n pi plus 1, no, therefore 5 by 4. Is a tan 5 by 4. So, tan 5 by 4, no? Tan 5 by 4. Okay. So right, n is an integer number. Okay, but what is the possible values for x here? I think is 5 by 4 is possible, right? Otherwise, you put 1, then you get more than this, because you want to find the value c within this minus 5 by 2 plus pi by 2. Okay, c within this interval minus pi by 2. At least one value you can find it, because these three conditions are satisfying, no? Therefore, at least one value you can find it. Okay. Therefore, I think that value is 5 by 4, right? You put n equal to 0, because natural integer number would n equal to 0, then you get pi by 4 belong to minus pi by 2 plus pi by 2. Therefore, this Rolle's theorem is verified for this question. Okay. Therefore, some questions we can't verify the Rolle's theorem because some conditions are not satisfying, then you can't verify it. Suppose if three conditions are satisfying, you can easily verify it. Then within that interval, you can find such a point. At least one point you can find it. Here we found one of the point, no? Like that. Suppose more than 1 point you can find it. It's no problem, right? At least 1 point you can find it. But more than 1 point also you can at least no. Then more than 1 point also you can't find it. Okay, that's okay. Some question you can't verify the Rolle's theorem, right? Because at least some condition are not satisfying, then you can't verify the Rolle's theorem. Okay. Okay, Rolle's theorems verified. Rolle's theorem verified. Okay. Next question, right? Right. Next question. Next question. Next question. Discuss the applicability of the Rolle's theorem. Applicability of Rolle's theorem to the function to f of x equal logarithm log a square plus ab a plus b x in the interval a comma b. Okay, in the interval a comma b. Okay, in the interval a comma b. You want to check whether this Rolle's theorem condition satisfying or not for this function at this interval. Okay, right. First, you want to find whether this function is differentiable or not. Okay, right. How can you find the differentiable or not of this function? If it's differentiable means left differentiable equal right differentiable, then you can say that this is differentiable function, right? That's the thing I will do for these problems. Okay, right. For this, first you take it's a notation, right? Left limit, so right limit, this one. What is the formula? This for this one, h length 0 plus, right? F of x plus h, f of x, h. Is it okay? Some books they can define this one is different way, but I will teach like this. Here f plus dash f of x. That means it's a right limit. Okay, it's a right limit. Left limit you can denote by f minus plus dash x. Sometimes they will put x as one of the point a, then we put here a, and here a, like right. It's a right limit. Okay. First you find the right limit, then you find the left limit. Both are equal. Then you can say the differentiable. Suppose if it's differentiable, implies if it's continuous, then you go and check that third condition. F of a equal f of b, whether f of a equal f of b or not. Suppose if equal, then you can use the Taylor's Rolle's theorem. You can find the at least one values within this interval, open interval a comma b, such that f dash of x equal to 0. Okay, now we will do. First, you find the right differentiable. Okay, for this one, 0 plus limit of h length 0 plus. You can take 1 over h outside. Okay, 1 over h outside. Here log f x plus h means you put log x in terms of x plus h, no? Then x plus h to the power squared ab a plus b x equal x in terms of x plus h. S you can write x plus h minus again log this one s squared ab a plus bx. Then this simple idea, you want to simplify, right? That's one easy. Limit h into 0 plus 1 over h log. What is the value? You can put for common log, you can take common log, right? Log this one over this one. Then you simplify it. Then you get, you can simplify this one s squared 2hx plus h squared ab. Okay. Into, suppose you put this one is a denominator part, this one, and then this one term should be here, a plus bx. Denominator part of this one, a plus b x plus h, this one is here. Next, this term cancel. You can write x squared 2hx ab s squared plus, we can take some, we do some arrangement, okay? X over, remaining x over this one, x plus h. Okay. Into x plus h there. Into x over x plus h. Okay. Next, now, okay, now okay. Next, here this term is same. Then put 1. Here also you put, you add plus h and subtract h, then you get 1 minus h over x plus h. Suppose you add here plus, then you can add here minus. Now what is the expansion of 1 plus some x over y? Now you want to, what is the expansion of ln 1 plus x or something? 1 plus ln 1 plus x, ln 1 minus x. What is the expansion? Right? You can recall these two expansions. It's very important. How we can find this expansion using the Taylor series and Maclaurin? That one, from that one you can find this expansion. That expansion is very important, right? Because we want to simplify it, because you want to find the limit values. So the expansion is very important, right? Otherwise you can't find the values. You can't put directly that h values here. Then suppose you can find the if you find the expansion of this log, then you can easily find this limit. For this, I will recall the expansion of ln, then you can easily use that one. Ln 1 plus y equal y minus half y squared minus 1 by 3 y cube 1 by 4 y to the power 4 and so on. Okay, 4 and so on. It is the expansion, it's 4, right? 4 and so on. It is the expansion, right? You can apply here 1 plus your y term is this one. Here 1 y term is this one. And you can easily apply, then you can easily find the limit. Limit h tends to 0 plus 1 over h. First term is this one, 2hx plus h squared plus ab. Second term minus half also there, 2hx plus h squared plus ab to the power squared. Next term is plus minus, no, all terms are, sorry, here plus again minus, plus again minus. Therefore this again plus and so on. Okay, right. Minus, for this one, first term is minus h over x plus h, right? Second term is minus, here minus there, plus 1 over 2 already there, h over x plus h to the power squared and so on, right? So now it is easy. Suppose you take this factor only, you can cut the term h and x, you get 2x over x squared plus ab. Other terms consist h element, one of the term h, therefore h in the 0 means all are 0. Then your limit values for this part, right? For this part, your limit values. Limit of this one minus this one, therefore limit of this values means 2x over s squared plus ab. Limit of this values means only the h, this is answer should be, then you get minus 1 over x plus h, x into 0, you get minus 1 over x. Here h squared term there. Therefore, suppose you take this one h term here, then here you have another h term, remaining h term. Therefore, other term should be 0, right? Therefore, only you have, the first term is minus 1 over x. So, it is your right limit, okay? It is your right limit, okay? It is your right limit. Next, we want to find the, it is your right limit. Next, you want to find the left limit, okay? Okay, now we will find the um, it is a right limit. Next, we will find the left limit. Okay. Uh, okay. Is it okay? It is a left limit. You want to find the left limit values. Okay. For that, uh, for that minus limit of h less than the 0 minus, you can take minus 1 over h outside. Okay. Minus 1 over h outside. Then f x minus h is log x minus h squared ab a plus b x minus h log s squared plus ab this one minus 1 over h here log you can expand this one x squared minus 2hx plus h squared plus ab. I guess previous you find the right limit, the left limits are same ideas working on there, but so minus is difference, I think. Okay, yes, this expansion also different because here x minus h, no, that case s plus h. That's a different thing, but there's no difficulties. Okay, you can easily do it. A plus b x minus h here a plus b x s squared plus ab. You can take s squared plus ab terms, then you know what this thing here is. You can cancel this term, then you can take this one here and this one here, then 1 plus log you can write 1 plus minus 2hx plus h squared over this term s squared plus ab minus log x over x minus h x over x minus h. Now you can expand this one, then you can get the, okay, then you can get the value, limit values. If you expand this one, limit of minus 1 over h, right, minus 2hx plus h squared over s squared plus ab. First term. Second term minus half minus 2hx plus h squared over h squared plus ab to the power squared, again plus and so on. Minus, suppose you add plus h and minus h, you will get, I think you can simplify this one, you will write here 1 plus h over x minus h. So first term is h over x minus h minus, yeah, minus there, or minus there. Okay, minus this one again plus h squared over x minus h squared and so on. To put bracket this minus here plus, okay. So if you find this limit values, you will get here limit h tend to 0 minus left limit. I think here h is cancelled, you get minus 2x over s squared plus ab. Other terms have h term, they have other sources are 0. Here also h tend to 0 means suppose you take here h is cancelled, then h is 0 means 1 over x, minus 1 over x, right? Minus 1 over x. Therefore, this value is also 2x over, okay, 2x over s squared plus ab. Because here minus there, here minus become plus. Next, here minus there, here minus become plus, right? Plus, but already, right? Is it okay? It's minus there. Yeah, minus minus become plus, again minus there. Yeah, because this expansion is, first term is h over x minus h, right? H is cancelled, x is 0, 1 over x, minus 1 over x. X plus, I think you get here 1 over x. Is it okay, right? Right. Here plus term. Now okay, right. Now okay, right. Then minus become, my plus become minus, then minus this one. Okay. Is it okay? Right. Then I think this both are equal, no? F plus dash x, f minus dash x. This is means f is differentiable, right? This means left. Hence, f is differentiable. For all value of x belong to a comma b. So f is continuous for all values of s belong to a comma b. Because f is differentiable, no? Therefore, f is continuous for all, hence f is continuous for all x belong to a comma b. Okay, now next here we prove differentiable, f is differentiable, therefore f is continuous. Now we want to check whether f of a equal f of b or not. Then you can apply the Rolle's theorem. Then you can you can find there, you can find the one of the um, at least one real number in this interval. The condition is f dash of x equal to 0. Uh, so now so now so now what is f of a? F of a equal to log I think this one is log 1 0 f of b. This one also 0. F of a equal f of b equal to 0. Hence, all the three conditions of Rolle's theorem are satisfying. Then, hence, all the three condition. Okay. Hence, all the three conditions of Rolle's theorem are satisfied. Therefore, f dash of x is 0 at least one value of x, at least one value of x in the open interval a comma b. That values you want to find it. Okay, at least one value exit. F dash of x equal to 0. Now your claim is you want to find the f dash of x. You have the formula f of x that you want to find the f dash of x. For finding f dash of x, you want to take the derivative, no? F dash of x. Ln derivative means a plus bx. 1 over means this one, a plus b over x, a squared plus ab, a plus bx into 2x minus a squared plus ab into a plus b over a plus b squared a squared. Now a plus bx a squared plus ab. Suppose you simplify this one, you will get, okay, a plus b a squared ab a plus b a plus b a squared. Suppose this one equal to 0, right? This one equal to 0, we will get the point x, okay? Zero. Then from this one you have this, you can cancel this term, right? A plus b squared non-zero. Okay, right. I think here this square term there, you can take outside, then this term is cancelled. So you have x over ab this a comma b are non-zero, therefore s squared is non-zero. Within this interval, you can find the x point x, no? Non-zero, non-zero, therefore non-zero, therefore s squared equal ab, therefore non-zero, no? Non-zero and a positive term, therefore only possible is square root of ab. Because you want to find this point within this interval, important, right? There's no possible negative value, no possible the zero values, therefore only possible this square root of ab, okay? For x value is square root of ab, right? Hence the Rolle's theorem is verified. Hence right, this interval does not consist zero values, therefore it is possible, right? Hence Rolle's theorem is verified, right? Okay. Now we stop, and in the next video I will do some problems, more problems about the Rolle's theorem and mean values theorem.